Okay, modelling question. Publisher, price of book, amount of profit made. If the price is too low, we won't make much profit. If the price is too high, we won't make much profit. That makes sense. Okay, let's have a look at the actual question. Explain how model A is inconsistent with one of the... Okay, I'll read the words later, but when we look at the mark scheme, see what you had to write. But model A says that the higher you make the price, the more profit you'll make. And assumption 2 is that if we make the price too high, we won't sell many, so overall we won't make much profit. So that's basically the answer to that. Okay, question 2. Given the equation of model B is quadratic, I'd assumed it was quadratic actually, just because it looks like a quadratic, but I guess it could be a sine curve, couldn't it? Could just be the first hump of a sine curve. So just because it looks like that doesn't, or it could be a quartic even, but upside down. Anyway, it's a quadratic apparently. Show that this equation is of the form t equals k 12p minus p squared. Find the value of the constant k. So this is a typical modelling question. They've given us a structure for the actual equation of the model, which is this one. And then they're going to give us information, and we can sub that information in to find our missing unknown. Standard modelling question. That's what all modelling questions are like. You find the information, sub the information in, find the missing value. If there's two missing things, like a k and a lambda or something, then we'd need two pieces of information. So we'd sub the first piece of information in, get an equation, sub the second piece of information in, get an equation, then simultaneous equations. Now in this one we've actually got three pieces of information. So which one did you sub in? Because we know that, because it goes through 0, 0, we know that when p is 0, t is 0. We also know that it goes through 12, 0, so we know that when p is 12, t is 0. And we also know that it goes through 6, 7,200. So when p is 6, t is 7,200. Okay, so what did you sub in? You subbed in t is 7,200, so you're not using that one because you subbed in p is 12. Oh wait, now p is 6. Okay, so you've subbed in p is 12 and p is 6 at the same time. P can't equal 12 and 6 at the same time. So our piece of information that we have to sub in is a point on the graph. One point is one piece of information, get subbed in together. So you can sub in p is 6 with t is 7,200, or you can sub in p is 0 with t is 0, or you can sub in p is 12 with t is 0, but not a mixture jumble of all of them. I'm wondering actually whether they didn't even have to give us the equation in its factorised form, because they've given us three pieces of information. We can actually do this all by ourselves if we want to, because let's see what they're telling us. Let's pretend they didn't give us that, right? But they do tell us it's a quadratic. It's definitely a quadratic. Then there's a couple of ways to think about the information we've been given. We've been given a root 0 and another root 12. So that means that we know that the factorised form is p minus 0, p minus 12. Now that's not the end, because there's infinitely many quadratics go through 0 and 12. Look, here's another one. It's just steeper. Here's a positive one that goes through 0 and 12. Here's a really steep positive one that goes through 0 and 12. So the whether or not it's up or down depends, and how tight or open it is, depends on the multiplier at the front, the a in ax squared plus bx plus c. So at the moment, my quadratic that I've written, p minus 0, p minus 12, that's got a coefficient on p squared of 1. P squared, la la la. So that's a massive assumption that definitely isn't true, because my quadratic is negative. So I'm going to put, I could just put a capital A there, but I'm actually, to make my own life a little bit easier, because I know for a fact that it's a negative quadratic, I'm going to put a minus A, and then that means that the A is a positive number. You don't have to do that. You could put just an A, and then A will come out negative. If you put minus A, A will come out positive. And you will see this done when we do differential equations. When we are making a differential equation, if something is decaying, we'll say dy by dx equals minus k, We don't have to do that. We could just say k, and then k will come out to be negative because it's a decay. But either way, it doesn't make any difference. You can put the minus on or not put the minus on. So what happens if we tidy this up a bit? Minus a p minus 12. I'm going to put the minus sign and the p into that bracket. So I'm going to leave the a at the front, but I'm going to put the minus p inside, so it'll be minus p squared plus 12p. And that's what they gave us, look. T equals, okay, they used a k, not an a. Number we do not know, 12p minus p squared. That's exactly what they gave us. So actually, in this question, they could have, if they wanted, just said, let's have a look, where is it? For part B, they could have said, given that the equation of the curve in model B is quadratic, find the equation of t equals. Just find it yourself. We're not going to put it in any form for you. You've got to find it. And then we would use those two pieces of information, the roots, the 12 and the 0, to get us that far with just one unknown. And then that would have used up this one and used up this one. And then we would sub in 6 and 7,200 into here. And that would get us the k. Now, we probably spent enough time on this one, to be honest, but I'll just show you the one other way that you could have thought about it. Where this is a root and this is a root. The other piece of information they gave us, it wasn't just some random point, it was the turning point. What form of the quadratic gives us the turning point? The completed square. So we know for a fact that this equation is going to be p minus 6, minus 6 squared plus 7,200. Because the graph has got, imagine a negative quadratic with its top bit, with its bump on the origin. It's gone right 6, up 7,200. Now again, there are infinitely many quadratics that have that as a turning point, just because that's its turning point. Could look like that, could look like that, could look like that, just because that's not the end of the equation. There's that multiplier at the beginning, which I called a. Okay, so now there is one piece of information missing, which is the a. We've used this piece of information. We've used the turning point piece of information. Now we can choose. We could sub in p is 0 and t is 0. So this is 0 and this is 0, and then rearrange that to get a. Or we could use the other piece of information. We could sub in p is 12 and t is 0 and rearrange to get a. Now the disadvantage of that way of doing it would be that then what you end up is the completed square form, and they specifically in this question want the factorised form. So then you'd have to expand out the completed square and then you'd have to factorise it. It's not a big deal, but it's easier to go for straight away for the factorised one. Okay, is that the end of this question? But no, oh my goodness. Part C, the publisher needs to make a total profit of, okay, so this is now going to be wrong, isn't it? Because sadly your K is not going to be correct. Because oh, one sec. Okay, so part C, publisher needs to make a total profit of 6,400, so T is 6,400. Use your equation to find the range of values within which the model B, blah, blah, blah. So we need to solve, first thing we need to do is to solve the equation to find P when T is 6,400. You've done that sort of, look, you put T is 6,400, but you haven't used your K. That you just, oh, I can see that you're not sure that that's the right K. That could be the right K. There's nothing wrong with that being K. Now, if you'd put that K in and then solved this quadratic by expanding out the brackets and putting the 6,400 on the other side, try not to use units in any equation. they should not appear. Once we're going mathematical, they should not appear, the units. Yeah, so you would just solve that quadratic. You know how to solve quadratics, get it all on the left, quadratic formula or factorising. You know how to do this. But do you know what it reminds me of? The fact that this one got abandoned. It's a quadratic, right? You know the whole quadratic. You've got quadratic equals something. You know how to solve a quadratic. Do you know what it reminds me of? Is paper 1, the question on here. Let me make that a bit bigger so you can see. Do you remember this one? It was a series question, and you ended up with this quadratic here. And it was the right quadratic, I think. But look, you've got 5 over n squared minus n, blah, 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 equals that. It's a quadratic equation. But you abandoned it. Because, I don't know, because you weren't sure, I think, about what you'd done in part B and part A. So it's exactly, look how much that cost you there. Now, even if something had gone wrong before, if you'd just solved the quadratic, using the quadratic formula even, you would have picked up method marks there, possibly even 2, probably 2, because you'd get a method mark for putting the equation together properly, and then you'd get a method mark for solving it. So of these 3 marks that were dropped, I think the exact same marks are going to be dropped here. In this bit here, the exact same 3 marks, which is confidence. I think that's what's happening. Either that or you're not recognising that what you're looking at is a quadratic. One of those two. But definitely spotting quadratics, solving quadratics, being more confident on carrying on even if the first 2 bits feel a bit wobbly. I think that's definitely something that we need to work on. D, comment briefly. Oh, I'll look at the words later. They're just annoying.